Okay, so today we're going to be going over rate and number patterns. So our agenda is homework review, then rates, and then number patterns, and then a Kahoot to review.
Okay, I don't think there's a homework review because, yeah. So we're just going to skip it and go straight to rates. So rates. Well, actually, first unit conversions, because when you're doing rates, you need to make sure your units are right, because you can't just do miles per minute if it's asking for miles per hour. So unit conversions. It's just what the name sounds like. You're changing from one unit to another. So if we take the example of your leftover Halloween candy, let's say, oh, never mind. Okay, I thought that was an example problem right away. So these are useful in rate problems. And sometimes the unit conversions are simple and you can just do them really quickly in their head. But sometimes you have like many layers of unit conversions and then it all just gets really messy and confusing. So there is a good way to do unit conversions. So let's just say like you and your friend are trading your leftover Halloween candy and let's say you have like, we should have put lightsabers there, but whatever. If 7 starbursts, like to you, if 7 starbursts are like worth the same as 2 packs of M&Ms, then how many starbursts would be equal to 12 packs of M&Ms? So obviously this one's kind of easy. Like, you just multiply by 6 because but let's just say, but for now we're going to use this a different way. So basically, we have 12 M&Ms, right? Oops. Where is the pen? Okay. Hold on. Okay. We have, oh, it's not going. Hold on. It's not letting me edit. Okay, there we go. Okay, let's say we have, okay, you have 12 packs of M&Ms, so 12 M&Ms. And when we do unit conversions, we just treat everything like a fraction, okay? So 12 M&Ms over 1, right? 12 M&Ms over just 1. It's just equal to 12 M&Ms. And we want to convert it to starbursts, right? Because you're trading M&Ms for starbursts. So we want starbursts on the numerator and M&Ms in the denominator. We're multiplying by this thing. This thing is called a conversion factor. That's basically telling us how many starbursts is equal to 1 M&M, or just how many of each are equivalent. And the reason why we're multiplying by this conversion factor is because then these two M&Ms, there's 1 M&M in the numerator and 1 M&M in the denominator. So that means what happens when you have something in the numerator and the denominator, they cancel out. So we're going to end up having no M&Ms, but for now, we need to figure out how many starbursts is equal to 1 M, or how many M&Ms. Now, the question tells us that 7 starbursts is equal to 2 packs of M&Ms. So this is our conversion factor. 7 Starbucks equals 2 M&Ms. So we put 7 Starbucks over 2 M&Ms over each other because that's just equal to 1, right? So now this is basically how we set up the unit conversion. We have M&Ms that cancel out. We have our conversion factor here. And did I say Starbucks? I hope I didn't. And then that is equal to 42 starbursts. Okay, you can tell that I don't really have a clear distinction between them in my brain. So sorry about that. So 42 starbursts. So that's how many starbursts are equal to 12 packs of M&Ms. So you may be asking, why would we do this if you can just multiply by 6 and get it done with? Well, it's because when it gets more complicated, it's like, say you have like hours per minute or something like that, or hours per minute per like something else or something weird. It would be really confusing for you to just try to do it without this step-by-step method. So yeah, that's why it's useful. Okay.
Okay, so in
Okay.
the land
Oh
of
yeah.
ink, the money system is unique. One trinket is equal to 4 blankets, and 3 blankets are equal to 7 trinkets. In trinkets, what is the value of 56 trinkets? So we would want to find out, we'd want to find trinkets in terms of trinkets because um, you're given trinkets and you want to find how many trinkets that is. So we know that we want to have trinkets in the numerator, right? And trinkets in the denominator, right? So you have one trinket, and we're just gonna put it as T is equal to 4 blankets, right? So one T is equal to 4B. So this is just one, right? Um, and 3B are equal to 7D, or 3 blankets are equal to 7 trinkets, right? So 3B over 7D, right? And since these are equal, it's just 1 times 1, right? So that means we're just multiplying by 1 when we multiply this by the value of 56 trinkets, right? So we want the 56 trinkets to be erased, essentially. We want them to cancel out. So we put it in the numerator rather than the denominator. So we have D's cancel out, then the B's cancel out, and then we're left with the only unit, which is T, or trinkets, right? So now all we have to do is multiply, and we get 3 times 5 over 4 times 7, right? Which is equal, or sorry, not 3 times 5, 3 times 56 over 4 times 7. So 7 times 8 is 56, so that means we get 3 times 8 over 4, right? So 8 divided by 4 is 2, so we do 3 times 2, which is equal to 6. So that means that 6 trinkets is equal to 56 trinkets. So that is our answer. So obviously this wasn't too hard, however, for a lot of you. However, you still want to be able to know how to do unit conversions this way, so that if it is hard for you, or if you just want to make sure you're not messing up because the problem could be really long, you want to have it so that you want to know how to do it this way. So yeah, that is the
If you want, I can go over it again if you're a little bit confused. Okay. So we started with 56 trinkets, right? And we want to convert the unit trinkets into trinkets over here. So to do that, we multiply the original 56 by unit conversion factors, which basically tells us how many of one unit equals how many of another unit. So we have to convert from trinkets to blankets and then to trinkets. So this is actually 2 steps. So we multiply this 56 trinkets by 3 blankets over 7 trinkets, because the question told us that 3 blankets are equal to 7 trinkets. And since they're equal, that means this is technically just 1, so it doesn't change the value, it just changes the unit. So that's one unit conversion factor. And since both of these since this has trinkets in the numerator and this has trinkets in the denominator, they cancel out. And so this expression, just this part so far, is in terms of blankets. Then we have to multiply by a factor that will convert blankets to trinkets. And the question tells us that 1 trinket is equal to 4 blankets. So if we multiply by this conversion factor, 1 trinket over 4 blankets, again, that's just 1, so it doesn't change the actual value, it just changes the units. So, and then since the blankets in the numerator and the denominator, they cancel out, and so we're left with just the trinket unit, and then just a bunch of numbers, which we just multiply out to get 6 trinkets. Okay, that's good. Okay. All right, so now we're going to go over just speed, rates, and distance in general. So rate, these are sort of like the relationship between distance, speed, and time. Though really speed is just rate. It doesn't have to be like speed, it could just be like rate. So this one is, you just need to remember one. I would remember this one. Distance equals rate or speed times the time that it took to travel. So basically, you can use this relationship to calculate like how far someone traveled or how fast they traveled or how much time it took for them to travel that distance. So examples of problems that might need this would be any problem, pretty much any problem where someone or maybe two people are running laps, or if someone is filling up something like a pool, because if someone is filling up something like a pool, then the volume or height of the pool water would be like distance, and then the rate would be like how fast it's filling up. Um, and another one is just how long it takes for someone to do something. For example, if someone is painting a wall, then the amount of wall they have to paint would sort of be like the distance, and how fast they can paint it would be the rate, and time is just time. And if you need help remembering this, then just use this acronym DIRT. Distance equals rate times time. Got it? So that's an acronym if you need it. Any questions about this so far? Okay. All right, so let's look at this first example. So we have an ambulance and it travels at 40 miles per hour. Okay, so now and it can follow a 20-mile route. So we already have like 3 different things, so we should probably just figure out what is what. So the 40 miles per hour is the speed of the ambulance, and the 20-mile route, that's probably the distance it's going to travel, right? And then the question tells us that there's a helicopter, and it travels at 1 mile per minute. So 1 mile per minute, that's its speed. Notice that the speed of the helicopter is in different units than the speed of the ambulance. So the speed of the ambulance is 40 miles per hour, but the helicopter is 1 mile per minute, which that's pretty fast. And then the helicopter is going to travel 15 miles to get to the hospital. However, the question also tells us that the helicopter has to take 3 extra minutes to take off and 3 extra minutes to land. So how many fewer minutes does it take for the helicopter to complete its trip versus the ambulance? So in other words, we're looking for the time of the ambulance and the time for the helicopter to travel to the hospital. So let's just focus on the ambulance part first, which is just this top part here. So the ambulance travels at 40 miles per hour, so that's its speed, and it's going to follow a 20-mile route. So how much time would it take the ambulance to travel to the hospital, given the distance, which is 20 miles an hour, and the speed, which is 40 miles an hour? Yeah, it would be 30 minutes because remember, distance equals rate times time. So the time is equal to the distance divided by the rate. So the time would be the distance, which is 20, divided by the rate, which is 40. So that gives us half an hour. And since it's in hours, we can also just convert that to minutes, and we know that's just 30 minutes. Then we have the helicopter. So it can travel at 1 mile per minute, and it takes 15 miles to get to the hospital. So how much time would it take the helicopter to travel to the hospital? And for this one, you do have to be careful because this is in miles per minute. So you need to convert that to miles per hour. Do you guys want more time on this part? Or do you want me to just go over it? Okay, I'm just going to go over it. So I see two answers. So yes, it would be 15 minutes. To find this, we would find the distance, which is 15 miles. And then it says that the helicopter travels at 1 mile per minute. So we need to convert that to the speed in miles per hour. 1 mile per minute is the same as 60 miles per hour because you multiply both the numerator and the denominator by 60 minutes, since there's 60 minutes in a mile. So the helicopter would be traveling at 60 miles per hour, which is very fast. So that is 1/4 of an hour, which is 15 minutes. But here's the thing. We're not done yet because the question also says that a helicopter takes 3 minutes to take off and 3 minutes to land. So we'd also have to add 6 extra minutes for that extra time the helicopter took. So in total, the helicopter would actually take 21 minutes to travel to the hospital. And now, since we have the time that it takes the ambulance to travel, which is 30 minutes, and the time it took for the helicopter to travel, which was 21 minutes, we just find the difference between them. And so 30 minus 21 is just 9 minutes. So the helicopter takes 9 fewer minutes to travel to the hospital than the ambulance. Any questions? Okay.
Okay.
Okay,
So
Shani, you
example
have
2.
this.
Yeah. Okay. Example 2. Cammy is filling up a pool at a rate of 12 gallons per minute, but the plug is pulled, so it's emptying at a rate of 7 gallons per minute. If it takes half an hour to fill the pool, then how many gallons is the capacity of her pool? So let's just first write out distance, or volume in this case, is equal to rate times time, right? So in this case, we are trying to find how many gallons is the capacity of our pool, which is the volume, or the D in this case, right? So we're trying to find this, right? So we have question mark is equal to rate. And then the rate in this case, we have to figure that out, times the time, which is half an hour, right? And we are given the rates in minutes, so let's just say that is 30 minutes, right? Because we want everything to be in the same form of units, so it's easier to cancel them out, right? So we know that the volume is equal to the rate times time. So in the chat, what would the rate be for how much is actually being filled up per minute? So given the fact that it's emptying and it's filling up, what is the rate per minute of gallons that are being filled up, that the pool is filling up? Okay, so it is 5. Good job, Arian and Charles. So the rate is 5 gallons per minute, right? So okay, is equal to 5 gallons per minute, right? So we multiply that by 30 minutes, right? Because we're given that it takes half an hour to fill the pool to capacity, right? So we cancel out the minutes, right? And we just have 5 gallons times 30, which is 150 gallons, which means that the capacity of the pool is 150 gallons. So good job to everybody who did that.
Okay. Final question. This one is about how fast people can work. So Kate can paint a wall in 10 minutes, while Ben takes 12 minutes to paint the same wall. So if they work together, and how many minutes would it take them to paint that same wall? So for this question, it doesn't give us the distance, or in other words, like how much that they need to paint, but it really doesn't matter. Let's just talk about like what fraction they've painted so far. So if the total amount of wall they need to paint is 1, then we cannot just add the minutes. We can't add the minutes together because that's not how it works. We can add the speed together and use that to calculate the minutes, but we can't add the minutes together. So we need to calculate the speed that Kate paints the wall. So if Kate can paint the wall in 10 minutes, then that means her rate is 1/10. Since if the total amount she has to paint is 1, then and if she can paint in 10 minutes, then that means that in 1 minute, that means that she can paint 1/10 of the wall. Then that is her rate. Then along the same lines, Ben would paint 1/12 of the wall in that time. So therefore, if this is their rates, then their combined rate would be this added together. So 1/10 plus 1/12. That would be their total rate. And since they're working together, this is like the overall rate that they're painting at because they're painting together. So then to find, and so 1/10 plus 1/12 is 11/60. So now to find how many minutes they would take to paint the wall together, we would do 1 divided by 11/60. And that just gets the reciprocal, which is just 60/11 minutes. Any questions about this?
Also, I'd just like to clarify, the reason that we are finding the reciprocal is because we know that we are doing one wall, right? We're painting one whole wall, and we know the rate at what, like how much they paint in 1 minute. So we know that they're painting one wall, and then we know that they're also painting 11 walls, or 11/60 walls per minute. So when we divide by 11/60 walls per minute, we cancel out the walls, right? Because the walls are now on the numerator and the denominator, so they cancel out, and we're only left with the unit of the minutes, which is why we find the reciprocal. Because essentially all we want to do is cancel out the units that we aren't using.
Also, the reason we did 1/11/60 was because 11/60, well, okay, 11/60 is their combined rate. So if we do one whole wall divided by their combined rate, that gives us the time it took for them to paint one whole wall together.
Yeah. Any questions? Okay. So time and clocks. So clock and time problems can be very confusing because you aren't just dealing with a line, you're dealing with a circle. So it's good to know some basic rates for how each hands on a clock move. So on a clock face, 1 hour is 30 degrees on the hour hand, and then 1 hour is 30 degrees on the hour hand, and then 1 minute is 6 degrees on the minute hand. 1 minute is half a degree on the hour hand. 1 second is 6 degrees on the second hand. 1 second is 0.1 degrees on the minute hand, and 1 second is 1/20th degrees on the hour hand. So a way to remember this is remember the minute hand goes 60 seconds in a full cycle. So in 360 degrees, the hour hand goes 60 minutes in 360 degrees, and the second hand goes 60 seconds. Yeah, it goes 60 seconds in all of the 360 degrees. So if you just remember how much one full cycle is, you're able to figure out the degree measure.
In general, when you're just looking at, for example, like 1 hour is how many degrees on the hour hand, or minute to minute, or second to second, you can sort of figure that out because you can figure out that, oh, there's 12 hours and the clock is 360 degrees. So to figure out how much it travels in 1 hour, you just do 360 divided by 12 hours. The one that's probably the most important would be these top three, because these two you may be able to just remember by yourself. This one is also pretty important because sometimes they like to ask you, like for example, in 1 minute or in something minutes, and say like 15 minutes, how much did the hour hand travel or something. So I say these top three are like the important ones. The other ones you can probably calculate. Okay, does anyone want us to pause on this slide for a little longer?
If not, then I can explain the first example.
Okay.
Okay. So, example 1. How many minutes will it take for an hour hand to turn 83 degrees? So, in this scenario, we want to know how many minutes, how many degrees the hour hand turns in 1 minute. So that will give us a baseline. So we know that the hour hand goes, it takes 60 minutes to go through the entirety of the circle. So that means that it will, or sorry, it doesn't take, it takes 60 minutes to go to 1/12, right? So it takes 12 hours to go the entirety of the circle. So because it takes 12 hours to go the entirety of the circle, it takes 30 degrees to go to 1 hour. So that means it takes 30 over 60, which is 1/2 degrees per minute, right? So now we have been given 83 degrees, right? So we know that 0.5 degrees go by every minute, right? So that would mean every 2 minutes we go 1 degree. So that means that we're not dividing by 2, or we're not multiplying by 0.5, but we're dividing by 0.5, because we want to do 83 of those 2 minutes. So we just do, because those 2 minutes are 1 degree. So 83 degrees multiplied by 83 degrees divided by 0.5 degrees per minute is equal to 166 minutes, and therefore it takes 166 minutes for the hour hand to turn 83 degrees. So good job to everybody who got it in the chat.
Okay, second example is a little bit harder, but not too much. At 12 a.m. midnight, the angle between the hour hand, oh, why was it 0.5 minutes? Because you have 360 degrees in a clock, right? 360 degrees. And the hour hand, how much time is it going to take to travel those 360 degrees? 12 hours times 60 minutes per each of those hours, right? So then that's just 300. So if the clock takes 12 times 60 minutes to take 360 degrees, then that means the clock will travel 0.5 degrees in 1 minute. Or at least the hour hand. The hour hand will travel 0.5 degrees in 1 minute. Okay. All right, second example. At 12 a.m. midnight, the angle between the hour and minute hand is 0 degrees because they're like this. They're like on top of each other. So how long in minutes would it take for the hour and minute hands to create a 33-degree angle? So this one is a little bit different because in the first question, we were just asking about one hand, like how much would it take one hand to turn 83 degrees. But for this one, we're asking about both hands, and it's kind of weird because they're both turning at the same time. Like your minute hand might travel like, I don't know, 1 minute. Like it's gonna like 1 minute. It's the minute hand's gonna travel like 6 degrees, but the hour hand is also going to travel like a little bit too. So you can't just find, oh, the minute hand's going to travel 33 degrees in this amount of time, because the hour hand is going to also move a little bit. So in order to solve this question, we need to look at the rates of both the minute and hour hands and find the difference between them. because that will tell us by how much the gap between them is widening. So the minute hand in 1 minute is going to travel 6 degrees, right? And then the hour hand is going to travel 0.5 degrees in 1 minute. So that means by how much does the angle between them increase every minute? If the minute hand is traveling 6 degrees every minute and the hour hand is traveling 0.5 degrees every minute, the hour hand is slower, right? And the minute hand is faster. So, but since the hour hand is still moving, so it's not, so that means we find the difference between them to find by how much the rate at which the angle measure is increasing. So 6 degrees minus 0.5 degrees is 5.5 degrees. So this means that the angle between the hour and minute hand is widening at a rate of 5.5 degrees per minute. And it really doesn't matter what orientation the hands are in. This is just the rate at which the gap between them is widening. So we want this to be a 33-degree angle. And since that means we just do 33 degrees divided by 5.5 degrees per minute. And that gives us 6 minutes. That's our answer, because the units, the degree units cancels out and it becomes in minutes. So 33 degrees divided by 5.5 degrees is just 6 minutes. So it'll take 6 minutes for the hands to reach a 33-degree angle from each other. Any questions about this? Okay. Well,
Example 3. So what is the measure of the acute angle formed by the minute and hour hands of a clock at 11:40 p.m.? So to solve this problem, we need to figure out what the degree measure from 0, which would be 12 midnight or midnight, right? What the difference from that is for the hour hand and for the minute hand at exactly 11:40 p.m. So we would
oops.
That is, yeah, that looks a bit more like 12, kind of, but not really. Okay, anyways, okay, and yeah, not acute. Okay, so what is the measure of the smaller angle formed by the minute and hour hands at 11:40? So, first we want to see the hour hand, right? So the hour hand will have a measure of, so obviously the hour hand is at 11, so that'll be 11/12 to 360, which
Wait, Shani, no. It's not perfectly at 11.
I know. I'm saying that, and then you add the 40 minutes.
Okay. Sorry.
So, yeah, at 11 o'clock, it would be 11/12 of 360 degrees, right? But so this is equal to 330 degrees. And now we add the degree measure of the angle that is at we add the angle that is added to that hour hand at 40 minutes. So we know that every hour it moves 30 degrees, right? Every hour that hour 30 degrees. So we multiply it by 40 over 60 times that 30 degrees, which is 2/3 times 30, right? And that is equal to 20. So effectively what we get for the hour hand is 350 degrees, right? Because 330 plus that 2/3 of the 30 degrees, that's between 11 and 12, the hour hand. And then for the minute hand, now the minute, it has 360 degrees to travel 60 minutes. So that means every minute it travels 6 degrees. So that means at 11:40, it will be 40 times 60, which is 40 times 6, which is equal to 240 degrees. So it'll be at 240 degrees exactly, right? So we have to find the difference between these, right? Because that will be the measure of the angle between them, of the small angle. So we do 350 minus 240, and we get 110 degrees, right? So just subtract, and you get 110 degrees. So the measure of the smaller angle formed by the minute and the hour hand at 11:40 p.m. is 110 degrees. So does anybody have any questions? So remember that the hour hand moves every minute, the minute hand moves every second. So like, don't think that just because it's not the hour hand an hour doesn't mean it doesn't move. Like, it moves even in smaller increments, even at smaller increments of time. So keep that in mind.
Basically, it's saying that the 2/3 comes from the fact that the clock, the hour hand, right? It's not perfectly on the 11. It's actually a little bit past 11 because it's 11:40, not 11 o'clock. So the 40 part comes from, it's 40 minutes, right? Divided by 60 minutes. That gives the fraction of a like hour it has. In fact, I think it would be better to understand it this way. The hour hand, the proportion of the full circle it has traveled is 11 and 2/3 of the full circle, because it's 11 hours plus the proportion in minutes, which is 40 minutes divided by 60 minutes, which is just an hour. So the hour hand has traveled 11 and 2/3 of the full circle. And since it travels 30 degrees in 1 hour, we multiply that by 30 degrees to find the angle that the hour hand is at. Okay. All right, any other questions? Okay, one more question. It is 12 o'clock a.m. midnight, as it typically is in these types of questions. To the nearest minute, what is the next time that the minute and hour hands are at a 0-degree angle? So what would we need to do? So what would we need to, what is the distance that would have to be traveled in this problem to find the next time that the minute and hour hands are at a 0-degree angle? Because if here are the two clock hands, and the shorter one is the hour hand, and the longer one is the minute hand, this is essentially saying the gap between these are gonna like widen over time, right? Whoops. It's gonna widen. It's gonna get even wider. It's gonna get so wide that eventually the clocks are gonna the clock things, the hands are gonna meet up again. That's sort of what it's saying. So in other words, when does the gap between, let me use some markers. This is better. When does the gap between like the clock hands reach a full circle? Because when they reach a full circle, then the clock hands are, boom, they're on top of each other again. They may not be in the same position. They might be like tilted this way, but they've like met each, but the distance that between them is a full circle. So in other words, we do need to find the distance that the hour hand traveled, and we need to find the distance that the minute hand traveled, but we need to find the point where the distance that they've traveled, their difference is 360 degrees. Does that make sense to everyone? Okay, so let's do this in minutes because that's just easier. So in 1 minute, the hour hand is going to travel 0.5 5 degrees, and we just know that. And in 1 minute, the minute hand is going to travel 6 degrees. So by how many degrees is the difference between them changing each time? Well, that's just the difference in the rates, which is 5.5 degrees. So in other words, this is by how much for each minute, like how much it's like widening each minute. So after, let's say, like 1 minute, it's this much. After 2 minutes, it's like this much, and it keeps getting wider and wider. So we want the time when that difference becomes 360 degrees. And since it changes by 5.5 degrees per minute, we do 360 degrees divided by 5.5 degrees per minute. And we get, it's not a whole number, we get 65.45 with repeating decimals. So in other words, this is telling us that it's going to take roughly 65.45 minutes for this to happen. And since we have the time in which this is going to, the time that it takes for this is going to happen, we can now convert it to hours and minutes. So 60 minutes is 1 hour. So this is going to take 1 hour. And then there's 5.45 minutes. Oh, I just realized there's something confusing. Boom. Okay. So 1 hour, and then there's going to be 5 minutes and 45, a portion of a minute, but it says to the nearest minute. So this is just 60 minutes plus 5 minutes. So it's 105, 1 hour and 5 minutes. And since we're starting at 12 o'clock, this is just going to go back to 1:05 a.m. A question about why did we do 360 divided by 5.5? So 5.5 is sort of like the rate of change of the distance between the clock hands. So if like this is the hour hand, right, then the minute hand is going to move faster than the hour hand, which means that the distance between them is going to increase at a certain rate. So the 5.5 represents the rate at which the gap between the hands is increasing. And we divided 360 by that because we want to find the time when the gap between these two clock hands is 360 degrees, because that's when they're at a 0 degree angle again. So 360 degrees divided by 5.5 degrees per minute tells us the amount of minutes it's going to take for them to meet up again. Okay. Any other questions? Okay.
Okay. So we're going to be covering modular arithmetic, or number patterns, modular arithmetic. So before you get into modular arithmetic, we have to define what modulus or mod is. So it's a mod b is basically the remainder when you divide a by b. So just think modulus is remainder. So an example is 14 modulus 3 is equal to 2. So when you try to divide 14 by 3, you get 12 remainder. So remainder 2, you get 4 remainder 2 because that 12 is removed, right? So you have an answer of 2 when you try to solve 14 mod 3. So there are a number of patterns using modulus, and competitive math exams like Math Counts ask questions about them. Sometimes it's indirectly, for example, trying to ask for the last digit in a pattern that repeats. So I doubt that any of you are able to say what the last digit of 3 to the power of 233 is off the top of your head. So if you try to calculate it mathematically, it would probably take you forever, or what feels like forever, to actually multiply it out and figure it out, which is why we use patterns, right? We use the pattern of what the last digit is when you raise 3 to another power. So 3 to the power of 1 has the last digit of 3. 3 to the power of 2 has the last digit of 9. 3 to the power of 3 has the last digit of 7. 3 to the power of 4 has the last digit of 1. And then 3 to the power of 5 has a last digit of 3. So this repeats every 4 digits. So you would figure out what 233 modulo 4 is, because you want to find out which of these positions it is in, 1, 2, 3, or 4, right? So 233 is not divisible by 4, right? However, 232 is divisible by 4. So that means that 233 mod 4 is 1. So that means that it is the first position of the 1, 2, 3, and 0, right? So that means that its last digit is 3, right? So you may or may not have known this, but for many of you, this will probably be new. So remember that modulo is just right. That is the key takeaway from this slide.
Okay, so here's another example of using the modulus. So, and looking for patterns. So what is the units digit of 9 to the 22nd power? So you guys answer this question first. Okay, I'll go over it and let's see who's right. 9 to the first power has the last digit of 9. Okay, that's not a surprise. 9 to the second power has the last digit of 1. Okay, so 9 to the third power, wait, let me write that. 9 to the third power has the last digit of 9. 9 to the fourth power, okay, by the time we see like a repeated digit like 9 and 9, then we know the pattern is going to be repeating. So in other words, when the power divided by 2 has a remainder of 1, then it'll have a last digit of 9. But if the power divided by 2 has a remainder of 0, in other words, the power mod 2 equals 0, then it'll have a last digit of 1. So since the power is even, this means that, in other words, 22 mod 2 equals 0, then that means we know this thing is what we're looking for. So the units digit would be 1. Okay. Second question. Shauna, do you want to do this?
Yeah, sorry, I had to unmute. Okay, so what is the units digit of 7 to the power of 11? So I will let you all do this. So I'll give you 2 minutes-ish.
Does anyone else need more time? If you want more time, say it.
Okay, if you all do not need more time, we can solve it. So 7 to the power of 1 is 7. It ends in 7, right? 7 to the power of 2 is 49, so it ends in 9. 7 to the power of 3 is 343, and it ends in 3. 7 to the power of 4 ends in 1, right?
2, 4, 0, 1. Yeah, it ends in 1.
Yeah. So it's 2,401, right? So it ends in 1. So we can see this pattern will be repeating since we're going to multiply this ones digit by 7, right? And we're going to get 7 again. So 1, 2, 3, 0. So now we have to find what is 11 mod 4, right? So 11 mod 4, 11 mod 4. Okay, so 11 mod 4 is equal to 3, right? Because it's equal to 3 because the remainder when you try to divide 11 by 4 is 3. So that means that we get this one over here. So that means that the units digit of 7 to the power of 11 is equal to 3. So good job to everyone who got it and everyone who answered. Oh, so the way to figure out what you divide the power by is how many numbers are there that are repeating. So are in the pattern. So since 9 to the power of x, it repeated every 2 digits. We did modulo 2, right? Because we wanted to find the remainder when divided by 2. Okay. And then when we did it for 7 to the power of 11, because 7 to the power of x repeats every 4, we did modulo 4. So yeah.
Okay, this one is a little bit different. It's not asking about the units digit. So what is the tens digit of 7 to the 81? And for this one, just do the same thing you've been doing previously. Just don't get afraid of saying like tens digit or whatever. Just look for patterns. Okay. Do you guys want more time? Okay.
Please don't.
Okay, I'm gonna go for it since there's a spam war going on. Okay, so tens digit of 7 to the 81. So let's just start, 7 to the 1, 7 to the 1 is 0, 7, right? So so that means the tens digit here is just actually 0. It's kind of weird. It's kind of an invisible 0. 7 to the second power is 49, so the tens digit is 4. 7 cubed is 343, so the tens digit is 4. 7 to the 4 is 2,401, so the tens digit is 0. 7 to the 5th means it's time to get out my calculator, and and it equals 16,807, which means that the tens digit is 0. Oh, hey, do you notice a pattern? Isn't it interesting? 7 to the 5th not only has the same units digit, it also has the same tens digit, which means that whenever you multiply by 7, since the last 2 digits is 0, 7, that means the next one in the pattern will always be 449, and that means when you multiply in, it'll always be 43 and then do 0 for 1. So in fact, the pattern is 0440. It's not 4400, it's 0440. And now we just use the mod trick. So we find the remainder when it's 80, since this pattern has 4 terms, even though two of them are the same, we still do have to use 4 because it's repeating 4. So 81 mod 4 is 1 because the remainder when 81 divided by 4 is just 1. So therefore, it's the first one. So the answer is 0. That is the 10th digit of this gigantic number. And if you type 7 to the 81 into your calculator, it will give you an answer. It's just you can't tell what the 10th digit is because it gives you like, no, it doesn't give you that small. Okay. Any other questions about this question?
Wait, are we doing the Kahoot now?
The what?
The Kahoot.
Yeah, let's go do that.
Yeah.
Okay. Yeah, okay, we only had one other question to do, so that Kahoot was like on time. Discard. Okay. All right, we got a Kahoot, guys. Not all of you are happy. Wait, can you hear the music?
No.
Well, actually, there's no music yet. Can you hear that?
I can't hear it.
Okay, then I will stop sharing. Actually, because music is like cool, you know? Oops. I don't know how that happened. I'll reshare in a moment. There we go. Oh, cool. My brother is playing. Oh, wow. Cool. Emoji. I mean, I don't even know if that's an emoji.
She probably meant to do the sunglasses one, but you know.
Hey, that's not me. Someone is impersonating me. Oh my gosh, it's me. It's that person who is me, apparently, which is not me, against my brother. That's interesting. Okay. Does anyone need more time to join? Or, like, can I just start?
Start. No, wait, give me a
Start?
second.
Okay, I'll wait a second. Is there a way to let people keep joining?
It should show unlocked in the bottom.
Yeah, but no. I think once it starts, it doesn't really.
Oh.
I don't know. Okay. Rates and number patterns. Yay. Okay. Number 1. The Martian traveled 1,000,000 kilometers at 10,000 kilometers per hour to reach Earth, which is interesting. I don't think that's a Martian. Isn't that from Plants vs. Zombies?
That literally looks like a toy.
Yeah, it is a toy.
That costs like
Looks like-
$5 at Walmart.
Yeah. I don't know who anyone would want to buy that. It just looks like nightmare fuel. Like, you would just wake up in the middle of the night and it's gonna be like looking down at you like, hi. Oh.
How is it 2 inches? Is it
How's it a
The answer
1,000?
is 100, not 1,000. So if you okay, that's not really. Okay, that was a typo. I did not make this Kahoot, so yeah.
That's what they all say.
What, say like I didn't make the Kahoot? Because I didn't make this. Butterfly goes 50 meters. Oh, I thought it. Okay, never mind. Okay, when I read butterfly in meters,
Why are these so simple? They're like third grade stuff.
I mean,
Someone got it wrong. So
Yeah,
Someone's
okay if you got it
definitely
wrong.
multiplying. Blue. How do you calculate the speed of a raindrop?
You just do rate times time. Rate
Wait, how
can,
do you see a raindrop? Like, how do you
I
calculate
mean,
where it's at?
you can use LiDAR.
Hide the cloud or something?
No, you use
Yeah.
LiDAR, then you can look at the raindrops. I don't know if that's how you actually do it, but that's how they look at clouds, so.
close enough.
Okay. Wow, Michael was in first place.
Thousand. Man, I misclicked.
Uh-oh.
Imagine.
Imagine if I'll get it wrong and it was the misclick that
What
was
type
the
of plane is that? It doesn't even have windows. It has 3 windows. So.
Okay, so this is just 200 divided by 0.5. So that gives you 400 miles an hour. Uh-oh, Michael Chen got a question wrong. Probably. Bow threw the ball 20 feet per second. It took 4 seconds to reach the catcher. How far did he throw in feet? This is an interesting graphic.
Kind of looks like a baseball.
Yeah.
I mean,
Okay,
like,
only
it's
one person got it.
obviously 80 since, like, in feet.
Oh, yeah. That's the only one in feet, yeah. I mean, the people who got it wrong probably just misclicked.
Yeah.
Who? Oh my gosh. Wow. That's interesting.
That's
I
like
did not
one
make
of
this Kahoot.
Yolanda trying to call you out.
I don't think Yolanda made the Kahoot.
It was
Do like some random Kahoot from the internet? I didn't make this Kahoot.
just a random Kahoot from the internet.
Everybody just likes to steal Amy's name. That is the only answer.
It was Kahoot. No, the answer.
10 apples equals 4 bananas and 8 bananas equals 3 pineapples. How many apples equals 3 pineapples?
Too many apples. Pineapple, apple,
Do you like apples, bananas, or pineapples better?
pineapples.
Pineapples, easy.
Bananas.
No doubt.
You like pineapples?
Unless you
They're
put salt.
amazing.
I like apples with salt.
Oh, that's interesting.
Yes, that is.
I don't like pineapples.
Salty apples are good. Just put salt on them.
Okay, 10 apples equals 4 bananas. So 10 apples equals 4 bananas. 8 bananas equals 3 pineapples. Okay, so we
Okay, so-
want
A way to think about this is also so 20 apples is 8 bananas, which is 3 pineapples. So that means 20 apples is equal to 3 pine. Sorry, 40. No, I cannot say. Okay, 20 apples is equal to 3 pineapples, right? So that means you just multiply both by 2, and you get 40 apples are equal to 6 pineapples. So that it's more of a simpler kind of thing than like
yeah,
written
that's
kind
one
of.
way you can do it. Okay. Okay, 2 pencils are the same price as 1 eraser, and 10 erasers is the same price as a book. How many pencils are 3 books worth?
Red. A pencil is yellow. It's yellow.
Bro, it depends what kind of pencil. Some pencils are so expensive for no reason. Like 15 pencils is not worth $10.
Yeah. The pencils they sell
pencils
at
are
like
like the
book
same
fairs
price.
are like priced like marked up so much.
Yeah.
Oops, that doesn't have media. Okay, so if we use like sort of the same thing like Shani said
Expensive.
last time, how many pencils are 3 books? So let's just look at 3 books. So 1 book is 10 erasers, therefore 3 books is 30 erasers. And then and now we just need, so 30 erasers. If 2 pencils are the same as 1 eraser, then that means 30 erasers is the same thing as 60 pencils. So the answer is 60.
Or the same thing.
Okay. If 3 penguins weighs the same as 4 cats and 12 cats is the same line, then how many penguins weigh the same as 4 lions?
Green.
Oh wow, almost all you guys got it right. So for lions, so it would be 48 cats. So 48 cats would be 3 times 12 penguins. So 36 penguins. Okay, how long will it take the hour hand to travel 45 degrees in minutes? Okay, so for this question, you have to remember that the hour hand will travel 0.5 degrees in 1 minute. So in order to travel 45 degrees, you multiply both sides by 90. And you get 45 degrees takes 90 minutes. Really? Oh, then okay, that's interesting. Then that means you are, okay, that's, oh wow, TH is in the lead. Oh wow, Amy Chen is in 6th then. How long will it take the minute hand to travel 18 degrees? Okay, so for this, you have to remember that for each minute, the minute hand will travel 6 degrees. Therefore, it'll take the minute hand 3 minutes to travel 18 degrees. So the answer would be 3. Okay, what's the units digit of this number?
X. 4 is
Okay, so yeah,
What?
the answer would be 4 because 4 to the first is just 4, right? But then 4 to the second is 16, so it ends in 6. And then if you multiply by 4 again, you get 4 again. So that means odd numbers will end in 4 and even numbers will end in 6. So the answer would be 4.
I pressed 4, but it didn't count. Weird.
Oh, maybe you ran out of time.
No, it was like 10 seconds before.
Oh, that's odd. I don't know.
It doesn't like you.
What's the, oh my gosh. Oh.
This one's very hard, totally.
It's really 30.
It totally is going to take you half a second to do it.
Yeah. Okay, the interesting thing about 6 is that what is 6 times 6? Well, 36, right? Oh, wait a second. Then if you keep multiplying by 6, it's just going to go 6s all the way down. So it's just gonna be 6. Yeah. Okay. What is the units digit of 2 to the 655th? Okay. So for this question, 2 to the 1 is 2. The pattern goes 2, 4, 8, 6. Okay. So we got that. So now we have to find the remainder when 655 is divided by 4. If you know your division rules, you'll know that you can just focus on the last 2 digits. The third digit doesn't matter. So what is 55 mod 4? Well,
3.
we know 52 is divisible by 4, therefore 55 mod 4 equals 3. So since it's 3, the answer would be 8, because it's the third one in the sequence. Alright, let's look at the podium. Okay, in third place we had Advika rules. In second place we have Aryan Eyes, which I assume is Aryan. And in first place we have Interesting Faces. Okay, runners up is Michael and TH. Who's Interesting Faces? Aryan? You're Interesting Faces, and who's Aryan Eyes? Oh, okay. Oh, it's Shawnee? Okay. Alright, then who is Michael? Charles is Michael. Alright, got it. Alright. So the final ranking is Aryan is first, Advika is second, and Charles, aka Michael, is third. What are people saying about scams?
I think they were scammed.
Scammed of what?
I don't know.
Oh, okay. Probably you probably missed a question. Okay, so I'll stop recording.